So in our first example, we have that a potato chip producer has just received a truckload of potatoes from its main supplier. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. Carry out a significance test at the alpha equals 0.10 significance level. Can the producer conclude that more than 8% of the shipment is defective? So first we need to start off with our hypothesis test. So our null hypothesis is going to be the proportion equals 0.08 for our 8%. Our alternative is that the proportion is greater than 8%, because that's when we would send the potatoes back. Next, we need to go through our checklist of whether or not we can perform a hypothesis test. So the first question, is it random? Well, it says that we select a random sample of 500 potatoes, so it is random. Is it independent? So each potato has an equal chance of having a blemish, so it's independent. Then lastly, is it normal? So we have 500 potatoes, and 8% of that is 40, which is greater than or equal to 10. And then we check at 500 times 0.92, which is 460, also greater than or equal to 10. So it is normal. So we can perform a hypothesis test. So our p-hat is the 47 out of 500 that have blemishes, which is 0.094. Our p-naught is the 0.08. N is 500, and lastly, alpha is 0.10. Okay. Next, we need to find our test statistic. So we take 0.094 minus 0.08, divide it by the square root of 0.08 times 0.92, all over 500. And we get 1.15. So when we draw our curve, we have our mean of 0.08, we have our 0.094, we're looking at the area above. So the probability, so if we use our z-score chart and we find our 1.15, the probability of being less than that is 0.8749. And when we do 1 minus 0.8749, we get our probability, which is 0.1251. Okay. We now compare our p-value, which is the 0.1251, to alpha, which is 0.10. And since our probability is greater than alpha, we fail to reject the null. So that means that I think it would be easier if I typed it out. So there is no evidence to show that the proportion of potatoes with blemishes is greater than 8%. So next, we have that according to the CDC website, 50% of high school students have never smoked a cigarette. Taeyeon wonders whether this national result holds true in his large urban high school. For his AP Statistics class project, Taeyeon surveys an SRS of 150 students from his school. He gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Taeyeon conclude? Give appropriate evidence to support your answer. So we're going to start with our hypothesis tests. So our null hypothesis is that P equals 0.50. Our alternative, so he just wants to know if this holds true, which means the alternative would be that the proportion does not equal 0.50. Then we're going to run through our checklist. So is it random? Well, he's conducting an SRS, so simple random survey, so we're good there. Is it independent? So each student has the same likelihood of answering whether or not they've smoked a cigarette, so it's independent. And then lastly, is it normal? So we only have to check one thing since our proportion is 0.50. So half of 150 is 75, which is greater than or equal to 10, so it is normal. So our P hat is the 90 out of 150 students, which is 0.60. P naught is our 0.50. N is 150, and since it doesn't tell us a specific significance level to look at, we use alpha equals 0.05. So our test statistic is going to be 0.6 minus 0.5 all over the square root of 0.5 times 0.5 all over 150. And we get 2.45. Okay. So we have 0.5 and we have 0.6. Now in this case, because our alternative does not equal, we have two regions. So when we do our probability, we'll find the probability of being less than 0.6, so using our z-score. So when I look at 2.45, we get 0.9929. So when I do 1 minus that, we get 0.0071. But we could fall in either, we have two probabilities to look at. We have the upper probability and the lower probability. So we have to do 2 times 0.0071 to get our p-value, which is 0.0142. So we now compare 0.0142 to our alpha of 0.05, and it is less than, which means we reject our null hypothesis. So when we're writing our statement, there is evidence to show the proportion of students who have never smoked a cigarette is not 50%. And whether that is greater than 50%, less than 50%, we don't know, but in Taeyeon's high school, it is not 50%. So the last thing we're going to do is we're going to look at how confidence intervals are related to significance tests. So a significance test tells us the statement about a parameter, and often a confidence interval tells us more and better information. So we're going to use this CDC problem and calculate our 95% confidence interval and compare the results. So just a refresher, the confidence interval formula is p hat plus or minus our z critical value times the square root of p hat times 1 minus p hat all over n. So for our problem, p hat is plus or minus, and then using our t-table, the critical value for a 95% confidence interval is 1 point, and then the square root 0.6 times 0.4 all over the square root of n, all over n, which is still 150. Okay. So we do 1.96 times the square root we get 0.6 plus or minus 0.0784. So when we subtract, we get 0.5216, and when we add, we get 0.6784. So we're still going based off our original hypothesis test, and we look to see, is our parameter inside our confidence interval? And our parameter is 0.50, and our confidence interval is from 0.52 to 0.68 pretty much. And 0.5 does not fall within our confidence interval, which means we reject our null hypothesis. So we can see how the confidence interval can also be used to determine if we're going to reject or fail to reject a hypothesis. 696. So the last thing we have to talk about is another way to perform a hypothesis test, a significance test. So we aren't always going to be able to find a p-value. All right? It's a good one, but sometimes it's difficult to find it. There's multiple steps. So there is another method we can use, and that's called a traditional significance testing method. So what that is a method that will determine whether to reject H naught based on the test statistic, which remember is Z, and a critical value. Okay, so next we want to talk about what that means. So you're gonna run the significance test all the way up into the Z score the exact same way. So you have your null, your alternative, your alpha, you find your test statistic. But where it differs is in the rest of it. So when we get to our curve, we're gonna then use our t-chart to find our critical value. And this critical value is gonna be based on alpha. And so we'll have what's called our critical region. Okay, and what we do is if our test statistic is in our critical region, we reject the null hypothesis. So if test statistic is in critical region, reject null. Okay? And then obviously if it's not in the critical region, we would fail to reject the null hypothesis. So we're going to take a look at a couple examples and see what this looks like in application. So our first example says, a study of high school students in America claims that 30% of students do not get enough sleep at night. You believe that this is too low and believe the proportion should be higher. To test this claim, you gather an SRS of 30 high school students, of which 14 said they did not get enough sleep at night. Test the claim at the 5% level of significance using the traditional significance testing method. So we're going to start off with our null and alternative hypothesis. So our null hypothesis is that the proportion equals 0.30. Our alternative, since you believe it should be higher, is the proportion is greater than 0.30. We're going to run through our checklist. So is it normal? And the answer is yes, because we're collecting an SRS. Is it independent? Yes. Is it normal? Now, 30% of 30 is actually 9, which is not greater than or equal to 10, but we're going to go ahead and assume it is normal for our purposes. And then 70% of 30 is 21, which is greater than or equal to 10. So we're going to just assume it's normal. So next we're going to find our p hat, which is the 14 out of 30, which is going to be 0.47. P naught is 0.30. N is 30. And because we're doing a 5% level of significance, alpha is 0.05. Next, we're going to calculate our test statistic. So we're going to do 0.47 minus 0.30 all over the square root of 0.30 times 0.7 all over 30. And we're going to get 2.03. So next, we have to figure out what our critical value is. So on our T-chart, we're going to look at the top where it says upper tail probability P. So this is where we're going to look at alpha. So we're going to find 0.05. Then we're going to follow that all the way to the bottom where we get our Z critical value. And we're going to get 1.645. And we have our upper region. So our next question, is our Z score 2.03 in our critical region? And the answer is yes, because 2.03 is greater than 1.645, and we've got the upper region. So because it is within our critical region, we reject the null hypothesis. And I'm not going to write the conclusion. You can do that on their own. But what this means is there is evidence to show that the proportion of high school students that don't get enough sleep at night is greater than 30%. And then our last example, it has been reported that 40% of the adult population participate in computer hobbies during their leisure time. A random sample of 180 adults found that 65 engaged in computer hobbies. At alpha equals 0.01, is there sufficient evidence to conclude that the proportion differs from 40%? So we'll start with our null hypothesis, which is going to be that P equals 0.40. And then our alternative, because we're seeing if it differs, our alternative is that it does not equal 0.40. So we're going to go through our checklist. Is it random? Yes, it says random sample. Is it independent? Yes. And then is it normal? So 40% of 180 is 72, which is greater than or equal to 10. And then 60% of that is 108, which is also greater than or equal to 10. So we're also normal. So then P hat is the 65 out of 180, which is 0.36. our P naught is the 0.40, N is 180, and alpha equals 0.01. So our test statistic is 0.36 minus 0.40 all over the square root of 0.40 times 0.60 all over 180. And we get negative 1.10. Okay. So when we are looking at our critical regions, we're actually going to have two in this case. Because we have the does not equal, we have to split up our critical region. So we have that we could be in either, our z-score could be in either critical region, and it would still, then we would reject. So when we do that, alpha has to be split in half. So half of 0.01 is 0.005. So we could, when we look for our critical value, we actually use our upper tail probability of 0.005. And we get 2.576. We could also be at negative 2.576. Okay, so now we need to check to see if our test statistic falls within either region. So negative 1.10 is not greater than 2.576, is also not less than negative 2.576, which means we fail to reject the null hypothesis. So what that means is there is no evidence to show that the proportion of adults who participate in computer hobbies is not 40%. Let me know if you have any questions over significance tests for proportions, whether it's to the method we were doing at the beginning of the video or the traditional significance testing method.